Here we will synthesize mandelic acid, an interesting aromatic alpha-hydroxy acid. First measure out 15 grams of benzaldehyde. Ours is a bit discolored but relatively pure and free from benzoic acid. First we need to create the bisulfite adductive benzaldehyde, so weigh out 30 grams of sodium bisulfite. This is more than we need, but the adduct forms better if you use an excess quantity. Add a stir bar and then add 50 milliliters of water. We need to dissolve the bisulfite in order to make a saturated solution. Stir well, and add water as needed to dissolve, but go slowly as the dissolution will take some time. We needed just over 60 ml of water and about 10 minutes of stirring. Now with vigorous stirring, slowly add the benzaldehyde to the saturated solution. Once all added, you'll see the adduct forming as a cream-colored, crystalline lumpy solid in the beaker, and you'll notice the temperature of the beaker rise. Once formed, it's very important to use a spatula to break up all the lumps in order to ensure all the benzaldehyde reacts. Spend some time doing this properly. Keep stirring for at least 15 minutes and beating up the lumps, and you should end up with a very fine precipitate like this. Once completed, you'll notice a quite significant temperature increase. Filter the precipitate, allow to dry, and then wash with 10 ml of cold water. It's worth noting that if you ever want to purify an adduct such as this, you can wash it with cold ether or dichloromethane in order to remove unwanted organics without dissolving the adduct. The next step is to nucleophilically attack our adduct using an alkali cyanide salt. We are using 15 grams of mixed sodium-potassium cyanide. This is in excess to what we need to use, but the reaction goes faster. Add 40 ml of water to dissolve most of the cyanide. Be sure to take care with cyanide salts in solutions. Place the adduct into a 200 ml beaker and add a magnetic stir bar. Add the cyanide solution, and begin rapid stirring. The adduct will slowly dissolve and form an orange-colored mixture. Continue stirring for 20 minutes. At the end of this period, you should see the mixture separate into 2 layers. Place the mixture into a separating funnel, and separate in. Reserve the oily top brown layer. This contains our crude mandelic intermediate. Place the aqueous layer back into the funnel and then wash this with 50 ml of toluene. This will extract out any dissolved mandelic. Separate the toluene layer and carefully dispose of the aqueous layer containing cyanide. Combine the product and toluene layers in the funnel, and wash with 10 milliliters of saturated sodium bisulfite solution. This will remove any unreacted benzaldehyde. Finally, wash the product and toluene mixture with 50 milliliters of saturated sodium chloride solution. Reserve the orange top layer and place into a 250 milliliters round-bottomed flask. The next stage of the reaction is to hydrolyze the mandelic. Add 40 ml of concentrated hydrochloric acid to the flask. This will form a lower layer. Stir the mixture using a magnetic stir bar, and set up for simple distillation. We will distill off the toluene from the mixture and perform the hydrolysis at the same time. As you distill, you'll see a mixture of toluene and water coming off, which will form layers in the receiving flask. A lot of HCl fumes are also produced, so be sure to use ventilation. After about an hour, you should have distilled off all the toluene. At this point, add a further 20 ml of hydrochloric acid to the boiling flask, and continue to heat for a further hour. Then transfer the remaining liquid into a 200 ml beaker, and boil it down on a hot plate until only 15 to 20 ml of liquid remains. As the liquid starts to cool, you'll immediately see crystals appearing. Add a few grams of salt to saturate the remaining hot liquid. This will help all the mandelic acid to precipitate. Chill the mixture down to form a thick slurry of crystals. Place these into a filter center, and then use vacuum to get as much of the orange liquid off as possible. It turns out that mandelic acid is not soluble in cold chloroform, so we can use this to get rid of some of the organic impurities. Add 15 ml of cold chloroform and break up the solid in the center. Then turn on the pump again and dry the solid as much as possible. We're now left with a crude mixture of mostly inorganic salts and mandelic acid. Mandelic acid is soluble in diethyl ether, whereas the inorganic salts are not, so we can use this to extract our product. Add 50 ml of ether to the solid obtained. You will see a large portion dissolving immediately. Stir the mixture well to get as much solid dissolved as possible. Then filter off the ether containing our product. The solid remaining should be washed with a further 40 ml of ether, and this filtered through again. Combine the ether portions and evaporate the dryness. Be careful not to allow the mixture to absorb moisture, and be very careful with inflammable ether vapor. Use gentle heat when removing the last bit of ether from the crystals, but don't go too hard or the crystals will melt and potentially decompose. We now need to remove organic impurities. We do this by adding 15 ml of chloroform to the product, and then gently heat until boiling on a hot plate, using a spatula to break up all the lumps carefully. Then chill this mixture down for 30 minutes until it is ice cold, and then filter the crystals. You can see the orange color fading. Wash the crystals again with 2 portions of 15 ml of ice-cold chloroform, drying thoroughly in between each wash. On the final wash you'll see most of the yellow disappear and the crystals will be almost white. If you have no chloroform, then dichloromethane will also work, but you will encounter greater losses of product. Here's our final dried product, off-white and odorless crystals of mandelic acid. We obtained 8.94 grams of product, which corresponds to a 42% yield from starting benzaldehyde. This is okay, but we're sure it can be improved. We will keep trying. Literature references suggest recrystallization from benzene, but this seems difficult, and the quantities of solvent required are large. This approach may be the next best alternative. Note that we have created a mixture of optical isomers of the product, 50% of each enantiomer of mandelic acid.